Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. Question 11. Nicole works at a local school 5 days each week. She drives an old car to work that has a 72% probability of starting on any given morning. The probability of the car starting on a given morning is independent of it starting on any other morning, so that's important. Independent, 72%, and then 5 days a week. Find the probability that Nicole's car starts on exactly 3 mornings in a particular 5-day work week. Alright, so, interesting question. Interesting question here. Try to see where we're in, or what kind of domain we're in. We've got a set number of trials. We've got a set of independent events where the probability remains constant over a set number of trials, and we have a success or failure, a kind of binary event. We have probability of success or failure. This tells us that we're in the realm of binomial distribution. Set number of trials, independent events, probability remains constant, and we have success or failure. So, we want the probability that Nicole's car starts on exactly 3 mornings in a particular 5-day work week. So, number of successes is 3. In this case, successes are defined as her car not starting. Number of trials is 5, and probability of success, or probability of it not starting, is 72%. So let's go to the calculator and work this out. Menu, probability, we have distributions, and here we have a binomial distribution. Number of trials, in this case, is 5. Probability of success, we're defining success as her car not starting, which obviously wouldn't be a success for her. Lower bound is 3, and upper bound is also 3, because we want exactly her car not starting. Oh, sorry, this is her car starting, I'm sorry. Her probability that the car starts is 0.72, so it is a success. Number of trials 5, probability of success, her car starting 0.72, lower bound is 3, upper bound is 3. We wanted exactly 3. There we go. So let's write this down for A. Binom CDF. We have 5, 0.72, and 3, 3. Okay. I think it's easier to stay within binomial CDF. Just remember your lower and upper bounds, and whether you're talking about exact or not. Alright, Nicole walks to work on mornings when her car does not start and it is not raining. Nicole takes the bus to work on mornings when her car does not start and it is raining. Okay. Where Nicole lives, there's a 42% probability of rain on any given morning, independent of any other morning. The probability of Nicole starting is independent of the weather. Okay, wow. Find the probability that Nicole will not have to take the bus in a particular work week. So this is her not having to take the bus. Okay. So a lot going on in this question. For probability in general, it helps if we can write it out in some kind of diagram. In this case, since we have independent events, tree diagram should probably be okay. And what do we want to find? We want to find the probability that Nicole will not have to take the bus. So she walks when her car does not start and it's not raining. She takes the bus to work when her car does not start and it is raining. So this is an interesting question. It's actually similar to the one before where we have this tree diagram where one of the branches actually stops in the end. So let's try to write this out from the very beginning and try to fill in a tree diagram. Often probability questions, if we can represent them graphically, they unfold a lot easier. So let's go ahead, give ourselves some space, and write out a situation. So her car can either start or it cannot start. It starts 72% of the time, and that means it doesn't start 28% of the time. Starts, she's good. She doesn't need to walk, she doesn't need to take the bus. And what is the case? If it doesn't start, she either walks or she takes the bus. So this is her walking, this is her taking the bus. She walks on mornings when her car does not start and it's not raining. So probability of her walking is equal to the car not starting, 0.28, times, so let's look at this. It's not raining, a 42% chance of rain. So if it's 42% chance of raining, we can write P rain is equal to 0.42. And P not rain, of course, would just be 0.58. What's left over? So she walks to work when her car does not start and it's not raining. So 0.58. This is her walking, so it's sunny because it's not raining. And then when it is raining, which happens 42% of the time, she takes the bus. So whether she walks or takes a bus hinges on whether it's raining, which is maybe a little challenging to try to tease out what this question is asking. So find the probability that Nicole will not have to take the bus. What can we do? Not have to take the bus. This is her taking the bus right here. We can find the probability of her taking the bus, and then her not having to take the bus would just be everything else. This is her not taking the bus, and this is her not taking the bus. So we could do this. We could do 0.72, and then we could do 0.28 times 0.58 and add those up. And that's her not taking the bus. And to be honest, actually, that's not all that bad. So let's do that. 0.72, 0.28 times 0.58 plus 0.72. Okay. So this actually is equal to 0.1624, saving as much of our digits as possible, or our levels of accuracy as possible. Let's write out the final value. So this is probability of not taking the bus is equal to 0.72 plus 0.1624. And here we have 0.8824. And if we wanted to be absolutely sure that this was the case, we would say, does this equal to 1 minus 0.8824? Sorry, it's 3 sig figs, we should round this to 2. And of course it does. 0.28 times 0.42. This is her taking the bus, and this is her not taking the bus. What's in red? So here we have it. Here's our answer in the end. This is a probability that she does not have to take the bus on a particular work week. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.